Here's another kind of, this is kind of like an identity type of thing as well. Let's write each function as a trig function of x alone. This is actually related to that last example. We saw example 3b. I think this is very related to that sort of thing. So let's do cosine 3x. Okay. Before you pause the video to try it yourself, let me give you a little hint. All right? So my hint is, you could think of this like cosine of x plus 2x, right? Which is exactly how we proved the double angle identity for cosine 2x in the first place. But pause the video now, okay? See if you can figure out the rest of the proof from there. So I'm going to go ahead and work this out, okay? So from this point, I can say this is going to be cosine x, cosine 2x. The sign changes. Sine x, sine 2x. I haven't quite finished because I need to rewrite this function as a trig function of x alone. And here I have functions of 2x, right? 2x. I know that sine 2x, I can rewrite that as 2 sine x cosine x. So I'm trying to think of the best thing to use here. If I rewrite this as 2 sine x cosine x, then I'm going to get a sine squared x and a cosine to the first power, right? So I'm going to get a sine squared and a cosine. So that kind of tells me that maybe I should write this as 1 minus 2 sine squared x. That way I have the same thing here, the same sort of thing here that I might be able to combine like terms on. If I change it into cosine squared minus sine squared, I'm going to get a cosine cubed and a cosine cubed and a sine squared cosine, which actually wouldn't be bad. So maybe that's something to try. If I change it into 2 cosine squared minus 1, then I'm going to get a cosine cubed and a cosine, and I think that's probably the ugliest of the possible answers. So here's what I think I'm going to do. I think I'm going to say cosine x. I think I'm going to use 1 minus 2 sine squared. And then minus sine x. This one I'm going to use just the tried and trues, 2 sine x cosine x. Anyway, I'm basically done now, right? Because I've accomplished the goal. I've rewritten the function as trig functions in terms of, x alone. But I could go maybe a little bit further. I could say, maybe I can clean it up a little, so I can say this is cosine x minus 2 cosine x sine squared x minus 2 sine squared x cosine x. Man, I really wish one of those was positive, then they would cancel. And I'd just get cosine. But that wouldn't be, cosine 3x equals cosine x, there's no way, right? So I think the best I can do is combine these two terms now. Yeah. Oh, okay, so I think I can make this even nicer. So I'm going to call this cosine x minus 4 cosine x sine squared x. And now what I'm going to do is rewrite this as 1 minus cosine squared. Then at least everything's just in terms of cosine. Although you're still going to have a cosine and then a cosine cubed. I don't know. This actually isn't bad the way that it's written. I'll just write out what I was thinking about out loud so you can see what I was trying to describe. But we could say, so this is cosine x minus 4 cosine x times 1 minus cosine squared x. Right? Does that make sense? So then this is going to be cosine x minus 4 cosine x. So I'm distributing this now. So cosine x minus 4 cosine x plus 4 cosine cubed x. And these things combine to get negative 3 cosine x plus 4 cosine cubed x. So there's another possible answer. I'm honestly not sure at what point the book would want you to stop on a question like this. So I'd be okay with this on a test unless I gave you some kind of explicit instruction to the contrary. But that one's okay. This one's maybe a little better just because it's all in terms of the same trig function, right? And it didn't say as trig functions of x, it said as a trig function of x. So maybe this is more kind of what they're shooting for in the problem. Okay, so there's one of these things. Just for the sake of completeness now, let's look at cosine 4x. We've actually already kind of talked about this in, again, in example 3b, because we were looking at sine 4x, and we said, well, we can think of sine 4x as sine of 2 times 2x, right? So the angle that you're doubling is 2x, right? And you can do the same thing here. So pause the video, give that a try. Okay. Here I go. So, another approach you could take, of course, would be to just call this cosine 2x plus 2x, or cosine x plus 3x, since you know what cosine 3x is now. Whatever, there are a whole bunch of ways you could do it. But I'm going to call this cosine of 2 times 2x. And we have a whole bunch of formulas for this thing. If we're trying to write this in terms of just a single trig function, then probably we should choose either the 1 minus 2 sine squared or the 2 cosine squared minus 1 version of the formula. So I'm going to call this, let's stick with cosine. So I'll call this 1 minus, sorry. For cosine, it's 2 cosine squared 2x minus 1. Now this still doesn't quite do the trick because we want to write this as a trig function of x alone. And right now it's written as a trig function of 2x, right? So we're going to have to apply that formula again here, I think. So here's how I'm going to think of this. 2 cosine 2x squared. Okay, that's just by definition, right? But cosine 2x, now I'm going to apply the double angle formula again. And I'll stick with the same formula and call this 2 cosine squared x minus 1. Okay, does everyone see that? So the cosine 2x became 2 cosine squared x minus 1. Okay, so I'm going to square this value now. So this is 2 times. Ooh, I'm running out of space. So I'm just going to square this in my head if that's okay. So when I square it, I'm thinking about writing it out twice. I'm gonna have this thing times itself, so that's gonna give me 4 cosine to the 4th. Then I'm gonna have this thing times this thing, right, for the outside. And then I'm gonna have that same copy again on the inside. So I'm gonna have negative 2 cosine squared x, negative 2 cosine squared x. That's gonna make negative 4 cosine squared x in total. And then finally I'm gonna have a negative 1 times a negative 1, and that'll make a positive 1. This 2 comes along for the ride, this negative 1 comes along for the ride, and we can simplify from there. So this is going to be 8 cosine to the 4th x minus 8 cosine squared x plus 2 minus 1, right? So I'm not going to write out the additional step. I'm going to say plus 2 minus 1, so plus 1. And there's my final answer. Okay. Anyway, pretty interesting. So here's what cosine 3x looks like. Here's what cosine 4x looks like. Right? But you can always rewrite these things just in terms of, you know, a trig function of just x alone, which is kind of nice. Okay. So I'm going to start a new video